I'm just going to go over some of the formulas and some of the questions for the test before the quiz, because when you look at this, you do not feel happiness. You feel pain and despair, especially because there's 63 questions on this one. It's like, what, 30 questions on this one? Yeah, this is I think, possibly the hardest part of Trig, just because of how annoying it is. But I will show you how to do it. I will show you how to do it with memorizing less formulas, and I will show you how to do it if you forget every single formula and it's multiple choice. You can just cheese it. Like, you can just put it all on the calculator and it will work. It doesn't even have to be that advanced. So we'll take this first question. And as formulas are needed, I will show you how to derive them. But, okay. So first thing I'm going to do is I'm going to write down a formula that I already think I'll need. So, okay, so first thing I do when I look at this is I look at the answer choices and I eliminate ones that I immediately think are going to be wrong. So, like, -2 tangent squared x, I very much doubt it. I don't know where that's coming from. We're not multiplying anything, really. I don't know where this 2 is coming from. It doesn't make sense. Everything else seems like it could be it. So we'll just keep those. So we are trying to get something along these lines. So we have sine x over cosine x plus cosine x over sine x. Now, obviously we know that this is tangent x plus cotangent x because of the reciprocal, or not reciprocal, the quotient identities. But we can't really do anything with this. And it's a lot easier to convert when you have sine and cosine. So these two fractions can't interact in any way. Like, they can't touch each other. There's nothing they can do. So what do we do? And the only thing I can think of is to combine the fractions by making them like denominators. So I'm going to do sine over cosine, and I need the denominator to have sine in it, so I'm going to multiply by sine over sine. That'll give me sine squared x over cosine x sine x. Forgive my handwriting, I'm using a mouse. And then I'll do the same thing on this side, so this denominator needs to be sine cosine, because that's the lowest common factor, denominator, whatever. So I will multiply cosine over sine by cosine over cosine. That'll give us cosine squared x over sine x cosine x. And since we multiplied the same thing over the same thing, this is just 1. This is just 1. All we're doing is we are changing the numbers, but the actual value doesn't change. We're just multiplying essentially by 1 and giving them like denominators. So if I take these and I say, okay, sine squared x over sine x cosine x plus cosine squared x over sine x cosine x, you should already see where this is going. As soon as you see sine squared x and cosine squared x, and there's things being added, you should already know that our super magical boy Pythagorean identity, which is sine squared x plus cosine squared x equals 1. This is really important that you know. And actually, I'll tell you right now why this is so important. The reason is, let me see if I can move this. The reason is because from this formula, you can derive the other two Pythagorean identities. You only need to know this. So let's say I need to know the one with tangent squared x in it. Okay, so I'm going to take this base function, and I'm going to do this. Divide everything by cosine squared x. Because we want tangent squared x, which is sine over cosine. So divide everything by cosine squared x. Keep in mind, we are not changing anything about the expression, the value, nothing. We're just dividing everything by the same thing. So we end up with tangent squared x plus 1 equals, because this is 1, equals secant squared x. And just like that, that's another formula. But you don't have to memorize it. You wanted tangent squared x, so you divide everything by cosine squared x so that you get sine over cosine, and then everything else just followed. And you can do the same thing with cotangent. So you can say, here, let me erase these. You can do the same thing with cotangent. So you can say, okay, I want to get cotangent. So I divide everything by sine squared x. Cosine over sine, that's cotangent. See where I'm going with this? And then you end up with another Pythagorean identity, the third one. So you say 1 plus cotangent x, cotangent squared x, equals cosecant squared x. And just like that, from one formula, you have found 2. That's a third of the memorization you have to do. All you have to know is just how to derive. It's very important. So, moving back to this example, when you see sine squared x, cosine squared x, immediately. And whenever you really see a function that is squared, you should start thinking about those Pythagorean theorems, or Pythagorean identities, because they can be really helpful. So this would give us cosine squared x plus sine squared x is 1 over sine x cosine x. Cool. Now what? Let's look at our answer choices. Oh wait, they're right here. Well, it's probably not this one. Sine x tangent x. There's no sine in the numerator, so it doesn't really make sense. So it's got to be this, right? And I'll show you how we get that, actually. This expression here is equal to 1 over sine x multiplied by 1 over cosine x. 1 over sine x is cosecant x. And, wow, that's bad. And 1 over cosine x is just secant x. And there you go. So I'd say with these types of problems, you always want to convert into sine and cosine, because almost every single formula has to do with sine and cosine. Except for a couple like these, but for the most part, it's a lot easier to do so. So yeah, that's how we get our answer on that one. And I will not show this one, because this is just, all you have to do is distribute a property, then Pythagorean identity to get sine squared x cosine x squared x equal to 1, and then you just cancel things out. It's not too hard. This one, same thing, Pythagorean identity. You do sine squared x plus cosine squared x, that's 1. Tangent squared x plus 1 is equal to secant squared x, just like we have in our formula here. So that one's not bad either. You can see right here, it's the answer choice. So a lot of these are pretty self-explanatory with the Pythagorean identities. And we just show you how to do this one, or these types. You just have to make the denominators the same. So multiply sine over sine, multiply cosine over cosine. Then you can have these two interact. You can have the Pythagorean identity, make it into 1, and then figure it out from there. For verifying identities, oh, actually, I want to show you something first. There is a trick you can use on the calculator that makes it a lot easier, and I hate that it works. Let me pull up TI-84 online. So, okay. Let's say you're doing this question right here, right? What you can do is you can say, okay, where is it? You can say sine, and then use a placeholder value. So let's say 1. sine 1 divided by cosine 1 and then let's just put in parentheses, make sure we don't have any errors. Okay. Plus, so it's sine x over cosine x over sine x. Cosine over sine x. Now, this is just, these are test values. We're going to plug it in. We're going to get 2 point whatever. Okay, cool. Now, what you do is you take those same test values and you test all of these answer choices. You say, okay, let's see if, because we know this is the correct answer, I'm not going to waste time testing every single one, but secant x, cosecant x, cosecant x should be equal to this. They should be the same. And so if I plug the same x into both, they should give me the same answer. And I will do so right now, and we will see what happens. So, let's see, where is secant? I guess this calculator does not have it. That's okay. We'll do 1 over cosine x times 1 over sine x, because that's just cosecant and secant. And would you look at that? They're the same. So they're the answer. So if you ever forget formulas and you just like don't have time or you just can't figure something out, this is always there for you. And it will get it right if there's multiple choice pretty much all the time. I learned about this after taking my test when I took Trig and being told that someone else did it, and it made me very upset because it was that easy. So I hope that you can use it in yours. But let's see. Let's do this verify the identity question, because for these you don't have multiple choice, which can be a problem. Okay, I will take a screenshot of both of them. I will open them here. Okay, so this first one, again, these look very annoying and very challenging, but it's all about breaking them down into sizable or easy to use little parts. So 1 plus, I want to turn everything into sine or cosine if I can. So secant squared x is just 1 over cosine times sine squared x. So if I multiply it a fraction by that, it would just go in the numerator. So sine squared x. And if you look at that, that's just tangent squared x. So 1 plus tangent squared x. And then if you look at this, it looks real familiar. And as you can see, it is equals secant squared x. So this is verified by the Pythagorean identity. I imagine on the test you're going to have to just write out your proof and then put hey, I used the Pythagorean whatever. I don't know how his tests work, but okay, cosecant u minus sine u is equal to this. Okay, well, let's see. I don't know why they're saying u. I'm just going to put x because I don't like drawing that. So cosecant, I don't like that. 1 over sine x minus sine x. Okay, what do I do now? Well, I want these two to interact, so I'm going to put them on the same denominator. So I'll multiply both sides. Actually, I don't have to multiply both sides. This has a denominator of sine x. I can just give this a denominator of sine x. So what I can do is I could say 1 over sine x minus sine squared x over sine x. Now give me 1 minus sine squared x over sine x. Alrighty. So, we have this now. What do we do with it is the question. And I will say the answer is 1 minus sine x is real familiar. In fact, it was real familiar to this guy up here. Sine squared x plus cosine squared x equals 1. So what if I just subtract sine x from both sides? That means cosine squared x is equal to 1 minus sine squared x. And we got that right here. So that means that cosine squared x over sine x, and that easily maps to our final answer, because we just go cosine over sine times 1 over sine, times cosine, and that's cotangent times cosine, and we got cosine times cotangent. Perfect. So you just kind of follow that formula of, okay, simplify as much as I can, try to combine things, put them all in one spot, make them interact as much as possible, and then once I get them condensed, then use whatever formulas I can that mostly involve cosine and sine, and then get into a form you can work with and simplify from there. So that's how you do those. And I will just scroll down here. Yeah, this, the same thing. This right here is the angle addition and subtraction. Again, not too bad, but there is some inevitable memorization you have to do. But welcome to Trig. It's not going to get much easier in the memorization front, at least. This is as hard as memorization gets, and there's some tricks to help you with it. So it's okay. So as we know, as I hope we know, cosine alpha plus or minus beta is equal to cosine alpha cosine beta, and then the inverted, oh wait, it's supposed to be inverted, so it's like this. So whatever the sign is between, like in the parentheses, should be the opposite sign. So if it's positive, it's negative. If it's negative, it's positive. So that's what that sign means. And then sine alpha, sine beta. And then for sine alpha plus or minus beta, it's, I imagine, to remember this, I imagine cosine is co, like everything's together. So cosines are together, sines are together, and the trade-off for them all to be able to be at their own lunch tables is that they have to switch the sign. But that's okay. Sine, on the other hand, doesn't switch the sign. And everyone gets sat at lunch tables with people who aren't their friends. So you end up with sine alpha cosine beta. But the sign's not changed. And then you have cosine alpha. I always have trouble drawing that. Sine beta. And you'll notice that alpha, beta, always in the same order. You just kind of flip around the sines and cosines. But yeah, another way to remember is cosine is cosine, cosine, sine, sine. And then sine is sine, cosine, cosine, sine. Some people remember it like rhythm like that. I don't. I can't do that. It's just whatever way works for you. So if we have this right here, then I am going to make an expression that says cosine 5 pi over 18 minus cosine, I don't know why I did the minus there, 9. Remember, switch the sign for cosine. We do like that. We do sine sine. Now from here, you may think to yourself, how do I do this? I'm going to tell you right now, I have not the slightest clue. How would you solve this? I don't know. But what you can do is there's two options. Option number one is brute force with the calculator. This is the I don't have time and I don't care, and it usually works. If you're gonna do this, you got to commit to this early because it's just a manual effort of just typing in the buttons. But it will work. It will tell you the answer. You will get it right. At least most situations, it will work out for you. This is like not how they want you to do it, but if you need to, go for it. What they expect from you, however, is a little bit weird. So you have 5 pi over 18 minus pi over 9. Currently, I have no idea what either of these are when I put them in the cosine or sine. No clue. However, I can manipulate this so that I do know what it is. So 5 pi over 18 minus 2 pi over 18. Now, I want this to be in a form where I can actually use it. Okay, I looked into it. Okay, I looked into it just now. And I learned that I am overthinking it way too much. And the fact is, none of this is necessary. It will get you the right answer. Don't get me wrong. But 5 pi over 18 minus 2 pi over 18 is 3 pi over 18. That is pi over 6. What is cosine pi over 6? It's frickin' 3 pi over square root of 3 over 2. I don't know why I was doing all that. These formulas are undoubtedly important to know. I will not deny that. This will give you the answer. But this problem was very easy. And you don't need another formulas for it. Let me find one where you do, because I know there are some. This one is self-explanatory. If you know the formula, you say alpha, beta. So pi over 18, 2 pi over 9. Hooray, hooray. I don't know why we're changing signs. I don't know why we're flippy. There's no reason for it. Let's see. Okay. These ones are just a step after this. So once you identify alpha and beta, you say, okay, cosine, cosine, sine, sine. That means that it's cosine formula. So if I look at this one, say, okay. Also, I'm not going to do any work on here because I want you as the viewer to practice. Because if you do not practice, you will forget everything I tell you, and there will be no use to this video. So do your own practice on your own time. So this is just cosine alpha plus beta. Or alpha minus beta, because you have to reverse the sign. It's 5 pi over 12 minus pi over 4. Guess what? That's just pi over 6. If you're wondering how I did that, it's the same as before. 5 pi over 12 minus 3 pi over 12, which is equivalent to 4. So you just multiply by 3 over 3. And then you subtract, you get 2 pi over 12, 2 over 12, 1 over 6, pi over 6. Hooray, huzzah. Cosine pi over 6, right there. Find the exact value of the expression. Same thing as before, it's just with degrees. So this would be cosine 155 minus 35. That would be cosine 120. 120 is actually 2 pi over 3, I believe. 2 pi over 3 is negative 1 over 2, so that would be D. I am doing it very fast because I have a lot of experience with it, but if you just put it in a calculator, you'll get it as well. Complete the identity, 3 pi over 2 minus x. Now this one's a little weird. This one's a little annoying. But one thing you can think about is the graph of cosine and sine. So you say, okay. Actually, I think Desmos would be easier for this. So my drawing skills are not terrific. So you say, okay, I have cosine x, and I have sine x. If I do 3 pi over minus x, right? Let's do another cosine x. So you can see that this function right here, this is cosine, and this is sine, right? So what we're doing is we're saying, okay, negative x, and then we're doing a translation of 3 pi over 2. So we're saying, okay, I'm going to translate, because you remember from the previous unit how to do translations, right? So if I just reorder this a little bit so it fits the formula, it's going to look like this. I'm going to say, okay, this right here is the b, negative 1 is the b, and then this right here is going to be the, what's it called, the c value. So to find phase shift, we do c over b, so 3 pi over 2 over negative 1, that's negative 3 pi over 2. So we're going to move this function negative 3 pi over 2. And if you notice, that maps it directly here. And you might think, okay, great. Right? So you say, okay, so it should be just minus 3 pi over 2, and then parentheses. But they're not the same. And that's because of this negative x right here. And this negative x makes it so that the, because as you can see, so as you can see, you have the function we were given, right? And then you have sine, but they're not exactly the same. So what we ended up doing is we took the original cosine x, right? We shifted it by 3 pi over 2 to the left, and then we ended up all the way out here. And we took the original cosine function, and we just shifted it. So we shifted it 3 pi over 2 to the right. We ended up with this structure here. And so what this is equal to is not sine, but negative sine. And I'd say if you were to do this on your calculator, just map this out, map out sine, see how they relate, map out the other functions map out the other functions in the answer choices, see what fits. Because that's some function logic that's really annoying to remember about how, oh, if I translate it 3 pi over 2, then it'll actually map onto negatives. You don't need to remember that. It's okay. Just put it in your calculator. You should be fine. Or what you could do is do test values again. So you could do 0. You could do sine x. Actually, 0 wouldn't work because of the negative. It wouldn't matter. But you get the point. You can put in some test values, see what works, see what doesn't. Because you probably won't have Desmos on the test. This right here is similar. You just do the formula. So cosine, cosine, sine, sine. You put in 30 degrees, 45 degrees, which would be pi over 6, pi over 4, you get the answers for it, and then you condense, and then combine the denominators and everything like that. Same thing. Okay, we can do this one. So this one gives you a new formula, new fun toy to play with. We love new formulas. So I will say, it's always an option to just throw this in the calculator. If you got 5 minutes left on the test, and you might just have to take the credit you lose from not showing your work and just throw it in. Unless you get no credit, in which case you're fried. I don't know what to tell you. So sine a plus b, sine a minus b. Okay, so we get sine alpha cosine beta plus cosine alpha sine beta multiplied by the same thing except with a negative sign in the middle. So sine alpha cosine beta minus cosine alpha sine beta. Now, if you multiply these out, you will get sine alpha cosine beta squared. And then, since it's plus and minus are the same thing multiplying each other, then the middle term cancels out. Because if you have x minus 1 times x plus 1, you end up with x squared plus x minus x. They cancel out, and then minus 1 squared. Same thing here. So sine a cosine a squared, sine a cosine b squared, and then it would be minus cosine a sine b squared. Okay, I just consulted the tomes just to make sure that I'm doing this right. So there's two ways you can do this. So you end up with this after you spread the exponent. And I'm going to show you one way. So you can either convert sine using a formula or convert cosine using a formula. And the way you do this is you use the Pythagorean identity. So you say sine squared a alpha times 1 minus sine squared beta. Minus sine squared beta. So we would end up with sine squared alpha times 1 minus sine squared beta, because we convert cosine squared beta into 1 minus sine squared beta via the Pythagorean identity. We've done this before. And then we do the same thing over here. So we say 1 minus sine squared beta, or sorry, alpha, because that's this one, parenthesis times sine squared beta. And so if we multiply this out, we get sine squared alpha minus sine squared alpha sine squared beta. This may seem like a lot, but it'll be gone soon, so it's okay. Minus big parenthesis sine squared beta, that's this, minus sine squared alpha times sine squared beta. So what you'll notice is we have sine squared alpha minus sine squared alpha sine squared beta. Then we have sine squared alpha sine squared beta over here. So if we were to carry the negative, this would be plus and this would be minus. We could erase this. Right? And these two, thankfully, cancel out. So we end up with sine squared alpha minus sine squared beta. I hate that problem. Use a calculator on it. Oh wait, it's not here. Maybe think to yourself, oh well, it's time to give up. And that is not the play. Because there is a different method. We converted cosine using the formulas. We can now convert sine using the formulas the same exact way and get the right answer. So the right answer should look like this, but in cosine form, so it's probably going to be this. That would make the most sense. So I'm just going to pick that. If you check it, it's probably right. And if not, then flame me in the comments or something, I don't know. But for these types of questions, when you see this much algebra you have to do, either turn these terms into variables that are much easier to manipulate. So like you could be SA or something like that. That's a lot easier to write. That speeds up things a lot. Or just put it in the calculator. It's that simple. Yeah, I definitely would say put this in a calculator if you can. Or you should make them into variables that are easy to write, like SA for sine alpha. It just speeds things along a lot. But you're going to be doing a lot of algebra, and time is going to be your main enemy. Let's see. This is similar. This is going to be a lot of algebra. And I cannot be bothered personally, so either do the algebra with variables or put it in a calculator. Same here. Or you can't really put it in a calculator here, so you have to do it with variables. Okay, these questions. These questions I will show you right now. So, first step in these questions is to draw some triangles. So, sine alpha is equal to 8 over 17, and alpha lies in quadrant 2. So that means that if we have a unit circle, alpha lies in quadrant 2, so it's like that. This is alpha. And sine A is equal to 8 over 17. So we have 8 over 17. And then if we do Pythagorean theorem, just to find the other side, we do, I'm going to use a calculator for this, 17 5. So that would be, I forget what the square root of that is. I should know this. 15. Okay. This would be negative 15. Why is it negative? Why is it negative? It's in quadrant 2. Cosine is negative because you're going left. Sine is fine because it's going up, and the hypotenuse is always positive. And also it tells you. Okay. Next triangle. Cosine beta is equal to 12 over 13. beta is in quadrant 1. Cool. Quadrant 1. Cosine is 12 over 13. 12 over 13. This is 5. This is just a standard triangle. I will calculate it anyways, though, because I could be wrong. 25, yep, square root of that's 5. Okay, now we have our triangles. Now we have to find sine alpha minus beta. And now this is the most fun and amazing and great part. So we're going to do the formula. So we're going to say sine alpha cosine beta minus cosine alpha sine beta. Now what do we do? Well, we know what all these are. Sine alpha, if you look at alpha, sine alpha is 8 over 17. Cosine beta, if we look at beta, cosine is 12 over 13. Minus cosine alpha. Cosine alpha is negative 15 over 17. Always remember, when they tell you your quadrant, you need to make sure that you put the right negatives where they're supposed to be. You have the all students take calculus or whatever acronym you need, or just eyeball it, but if you don't get these negatives right, you will get the question wrong. So cosine alpha is negative 15 over 17. And then sine beta, 5 over 13. And now we multiply. 17 times 13, I have no idea what that is. 221. Wrong one. So 221, we're multiplying. 8 times 12, 96, minus 15 times 5, that should be 75. And this is a negative sign, so this would be plus. And then 17 times 13, same thing, 221. Like denominators, we can add them just fine. 96 would be 4, so that would be 100, 171. Let's see if my math is woefully wrong. It is not. It is not your choice. That is how you do those. You draw your circles. You make sure you get your negatives right. And then using that information, you get sine, cosine, and whatever tangent you need from these triangles, from alpha and beta. I suggest you try them yourself, because it seems easier in principle, but you forget steps sometimes. And these are all the same. Okay. Okay, so what we love to see is when we have to memorize the tangent formula. Tangent formula is always really hard for me. I had trouble memorizing it, but it's just one of the ones where you just have to thug it out. So the one for tangent alpha plus or minus beta, I believe, is equal to tangent alpha plus or minus tangent beta over 1 minus or plus, so it's the inverse of whatever sign this is, and then it's tan alpha tan beta. I am pretty sure this is the formula, because it looks an awful lot like this one. So you're just going to have to remember that. There's no better way. Try to make fun mnemonics out of it if you can, but it is difficult. But once you know this, it's tangent alpha plus or minus tangent beta over 1 minus or plus tangent alpha, tangent beta. You can immediately look at personalized these and be like, oh, okay, this is just tangent 25 plus 5, because this is plus or minus is the same sign. So 25 plus 5 is 30. It's tangent 30, tangent pi over 6. And as we know, tangent pi over 6 is just square root of 3 over 2 over 1 over 2, which is just square root of 3. Ding, 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 ding. If I'm wrong, you can... that would be very embarrassing. That would be very funny. But this is the same way. Look, you see the sign up here? So you're subtracting this time. So 70 minus negative 50, which is plus. That gives you 120, which is 2 pi over 3. Tangent 2 pi over 3 is reference angle is pi over 3. You do 1 over 2 over square root of 3 over 2, except it's negative because it's not quadrant 1 or 3. And so what you end up with is negative square root of 3 over 2, right here. Very simple. So if I need to slow down a little bit, all I did was I said, okay, this is the formula for tangent alpha plus or minus beta. So I just look at the top and I say, okay, this is the sign between the two. So it's alpha plus beta. It's alpha plus beta. So 25 plus 5 is 30. And then I translate that into from degrees into radians. So I get pi over 6. And then you just do tangent from there. You know how to do that. Same here. Use the sign right here. Make them interact. Whatever. This right here is the same thing. You draw your triangles, use the tangent function, and you multiply it out. It's a lot more algebra though. This right here is double angle formula, and I will show you that right now. Double angle formula, there are 4 of them. But really, you only need to know 2. Sine 2 theta is equal to 2 sine theta cosine theta. Wow. This one I found pretty easy to remember. I just imagine the 2 jumps out and then cosine gets added up. But for cosine, it's actually cosine 2 theta is equal to cosine theta minus sine squared theta. Now, the way you remember this is that it looks a lot like Pythagorean identity, except the cosine is the one in charge. He's subtracting this guy because he's the big dog. He's got the 2. And with this formula, you can do a lot of things. You can convert it. So you can say, okay, I want to say negative sine squared theta is equal to, so we'll look at the Pythagorean identity. So cosine squared theta plus sine squared theta equals 1. How do I substitute this for something? Well, I just subtract and subtract. So it would end up being cosine squared theta minus 1 equals negative sine theta. Sine squared theta. Okay, so what we do is we take this and we say, okay, cosine squared theta plus cosine squared theta minus 1. That's 2 cosine squared theta minus 1. Awesome. So that is actually another variation of the cosine 2 theta. And there's yet another one. And keep in mind, these may seem useless, but they will be important later, and they will save you a lot of memorization. Because you can just derive a lot of things from them. So we could alternatively convert the cosine to something else. So we could say sine squared theta minus 1 equals negative cosine squared theta. So if we do that, and we... Oh, actually you can't do that because this is negative. And that's positive. So we just need to flip the negative on both sides, so 1 minus sine squared theta equals cosine squared theta. Now we can substitute it. So what that'll give us is cosine 2 theta is equal to, see, cosine squared theta equals 1 minus sine squared theta. 1 minus sine squared theta. So it would be 1 minus 2 sine squared theta. So as you can see, just from this single formula, I'm able to derive these two. And from these two formulas, I'm going to be able to derive half-angle formula. I'm going to be able to derive all sorts of things. But this is important to know. Back to the question. Let's take a screenshot. Okay. Sine 2 theta. All we have to do is we do 2 sine theta cosine theta. Awesome. Sine theta is equal to 21 over 29. 21 over 29. Cosine theta is equal to 20 over 29. 20 over 29. 29 squared is a number. And it's probably 841, because that's a big number. And 21 times 20 is 840, so it's probably this. But I'm going to put it in a calculator. Not this one. Actually, maybe this one. So 21 times 20 and 29 times 29. Ah, 420 over 29 times 29. Oh yeah, and everything's multiplied by 2. Times 2. Yes, 840 over 841. So that's perfect. Oh wait, wrong question. It is this one. So I do not know the formula for this. And rather than trying to find it, I'm going to show you how to do without it, because I don't like it. So option A is brute force with a calculator, as always. And you're thinking, how do you do that with this? Well, all you have to do is just say, okay, if I have this theta and I know all the angles, I can just get do the inverse to get the angle, multiply by 2, and then do it again. So I say if tangent theta is equal to 21 over 20, opposite over adjacent, then what if I do inverse tangent 21 over 20? This is the angle to have in radians, probably. And now that I have that, I just multiply by 2. And then I do tangent again of whatever that is. Oop, not that. I think I accidentally tan inverse it again. I need tangent of this. So I get negative 20 point whatever. Okay. So it's not this. Actually, it could be that. Actually, it's definitely that. Yeah, it is that. Can't be this. Can't be this because it's negative. This is less than 1, so it's not that. And this is like kind of right. It's like 20 something. So it's that one. less work is always better, folks. Alternatively, you could just do sine 2 theta over cosine 2 theta. But you have fun doing the algebra for that. Because I'm going to be on the next question after doing my calculator, because I'm not doing that. If you need to know the formula, let me look it up. Tangent double angle formula. Tangent double angle formula is 2 tangent theta over 1 minus tangent squared theta. Yeah, no, I could not be bothered. Use your calculator. This is same thing. Draw a triangle, and then same thing we did here. Draw a triangle, get what sine is, and then do the sine 2 theta formula. Multiply everything out. You should be good. Same here. Write the expression as the sine, cosine, or tangent of a double angle. Okay. Well, let's think about the double angle formulas we know. Sine is double angle. Sine 2 theta is equal to 2 sine theta cosine theta. Does not look the same. Cosine 2 theta is equal to cosine squared theta minus sine squared theta. That is perfect. So, that would mean that we're going to write this out. Let me take a screenshot. Cosine squared 60 minus sine squared 60. If 60 is theta, and this is equal to cosine 2 theta, that means it's equal to cosine 120. And if it's cosine 120, 120 is 2 pi over 3. 2 pi over 3 is, for cosine, is negative 1 over 2. Ding, ding, ding. There you go. Could you find it out by doing this? Yes, you could. Should you? Honestly, with clean angles like this, it's kind of the same amount of work. If this was like 15 and 15, and you could only do it with a 30, then I would understand. But it's kind of equal when the angles are good either way. So just take it as you will. Okay, power reduction formula time. Yay, yay, yay! This is, I will tell you, this is quite possibly the worst thing you could ever be asked in a trigonometry class. The most annoying thing ever. Okay. So, I need the power reduction formula for sine. How do I get that? Well, I derive it from this big boy. So, all you have to do is isolate sine squared theta. So, to derive the power reduction formula, you isolate sine squared theta. So you say plus 1 over 2. So, cosine minus 1. Just subtract 1 from both sides, and then divide by negative 2. And then that would end up just flipping it around. Because everything would be negative, you flip the negatives. Okay. So, you get cosine that's just from doing the algebra on this. It's equal to sine squared theta. This is the power reduction formula. And the reason this works is because you take something with a power and it doesn't have a power anymore. As you can see, this is the correct formula because everything has cosine in it. So, great, you might be saying. Okay, We can get rid of the power now, right? No, of course not. It's never that easy. Because this is 4. How are we going to get rid of the 4? Well, here's what we do it. We say sine 4x is equal to sine 2x times sine 2x. Now you can do it. So you could say 1 minus cosine 2 theta over 2 times 1 minus cosine 2 theta over 2. Now you'll notice that we're not done yet. The reason for that is because we're multiplying here. So there's still more work to be done. So if we cross multiply, it's 4, and then it's 1 times 1 is 1, minus 2 cosine 2 theta plus cosine squared 2 theta. So the question is saying, make sure it doesn't contain powers of trigonometric functions greater than 1. So we are fried still. How are we going to power reduce this? Well, we just derived the other formula. So we want to power reduce this. So we're going to say plus 1 over 2 is cosine plus 1 over 2 equal to cosine squared theta. We can substitute that. So we're going to say cosine 2 theta plus 1 over 2, 1 minus 2 cosine 2 theta plus cosine 2 theta. But wait! Theta is 2 theta, so actually it's 4 theta. Let's take a look at this. Wrong one. Cosine squared some value is equal to cosine double that value. So if we are putting in 2 theta, we have to double it, so it's 4 theta. Amazing how that works, and just adds more effort and more work. But I will not complain. This is over 4. And now we do algebra. So we say, okay, we have 1 over 4 minus cosine 2 theta over 2 plus cosine 4 theta plus 1 over 8. Let's see what our answer choices are. Our answer choices are none of these. Okay, so we have to continue simplifying. So I can do 1 over 4, and then take this out, so plus 1 over 8, and that would be 3 over 8, minus 1 over 2 times cosine 2 theta. All I'm doing is just making this multiply, plus 1 over 8 cosine 4 theta. And as we can see, bada bing, bada boop, we have our answer. That is annoying, but you are going to have to learn it because it is important, and he will undoubtedly ask you to do this again, because it's kind of like a fundamental thing you just get asked. Knowing what you know from that last question, you can do the rest. You can figure that out. You can do the algebra. You've got that. I believe in you. Use the half-angle formula to find the exact... Okay. So, half-angle formula And what's great about it is you don't actually have to memorize it. Half angle is just saying, okay, if I put in an angle that's half of what I know, then I should get something double, right? So this formula is really close to what I need. So why don't I just square root both sides? Square root cosine theta, cosine 2 theta, plus 1 over 2 is equal to cosine theta. Now divide theta by 2, and you just have the half angle formula. Now isn't that wonderful? So with that, you can derive every formula from this one. Every single formula you can derive from this one. Half angle, double angle. You can derive these two guys. It's great. I love it. So yes, this is the half angle formula that we can use. So sine 15 degrees. We say if this is theta over 2. Oh, sorry, I have to derive the other one. It's actually sine, but that's okay. It's the same process. Square root. We end up with square root of 1 minus cosine 2 theta over 2 equal to sine theta. I suggest using the first 5 minutes of your test, just do all of this. It'll be helpful. Just derive all the formulas, don't forget. And this is half angle, because you can just divide by 2. Okay. So now, if we have 15 degrees, plug it in, and say, okay, sine theta over 2, 15 degrees is theta over 2, is equal to cosine theta, which would be 30. So 1 minus cosine 30, 30 is pi over 6, pi over 6 square root of 3 over 2, minus square root of 3 over 2 over 2. 2 minus square root of 3 over 4. And then all this is under square root. You could also say 2 minus square root of 3 over 4. And then this would be square root of 2 minus square root of 3 over 2. See if that's an answer. It is. So 2 minus square root of 3 over 2. Over 2 is the same thing as multiplying by 1 over 2. That works. Rinse and repeat. Radian measure doesn't matter. You can still multiply by 2. This you can multiply by 2. Tangent. Tangent double angle. I will not lie to you. Either use your calculator or do sine over cosine. So do the sine double angle formula over the cosine double angle formula and just thug it out. There's no real alternative, I'm sorry. Okay. Got that, same thing, just double angle. Double angle as well. You just have to push it around a little bit, just like we did in the first few questions. And okay, I have been sat here filming for over an hour and a half. This should be the final few concepts, hopefully. Okay, so we're going to look at this. Find all solutions to the equation. This shouldn't be too hard. So I say, okay, we have two cosine x minus 1 equals 0. We want to find all values of x that satisfy this equation. So I want to isolate x. So I want to say cosine x equals 1 over 2. Okay, cool. In what situation is cosine x equal to 1 over 2? Okay, well, it's equal to 1 over 2 in, well, it's positive in these two quadrants, and it's equal to 1 over 2 at pi over 3. So it's pi over 3 and 5 pi over 3. So x equals pi over 3, and x equals 5 pi over 3. Notice how they do not give you a clamp here. They don't say between 0 and 2 pi. They don't say 0 and 4 pi. They say just infinite. And so that's what n pi does. Essentially what it means is, if you were to add pi, no matter how many no matter how many pi's you add, it will be the same thing. But obviously that's not how that works, because the period of cosine is 2 pi. So if you were to add pi, it would just put you from here to here, which is negative, so it doesn't make sense, wouldn't work out. So in fact, you would have to do plus 2n pi. So what this is saying is that the answer is 5 pi over 3, and every coterminal angle that exists, everything, in either direction too. And same with this, we're going to do the same thing. So plus 2 pi, 2n pi. That'll be our answer. Try harder one. Oh, love it. Okay. You guys might be cooked, I'm not gonna lie. This test, you might be a little bit fried. I will not lie. Okay. Tangent x secant x is equal to negative 2 tangent x. What do we freaking do? Now I'm going to tell you what you shouldn't do. And that is to destroy stuff. It is so tempting. It is so incredibly tempting to do just divide both sides by tan x, get rid of it. It is. I want to do it. But you can't do it. And it sucks. But what you can do instead is what you did in the other problems. So it's just simplify this expression. So let's say sine x over cosine x times 1 over cosine x. Sine x over cosine squared x is equal to negative 2 sine x over cosine x. So what I will do is I will make these denominators the same. So I will multiply by cosine x, cosine x, sine x over cosine squared x is equal to negative 2 sine x cosine x over cosine squared x. And the reason I did this is so that I can actually make these two interact. They have the same denominator, so I can put them on the same side. I can make them subtract and stuff. So I'm going to add this to the other side. So I'm going to say sine x plus 2 sine x cosine x over cosine squared x equals 0. Okay. Now what do we do? Well, we can get rid of the cosine. Just multiply it. Multiply this by 0, gets eaten. Then what we will do is we will Okay, I'm out of time. If you need help with this one, throw it into AI. I'm just going to say a few more things. Um, for one thing, ask AI for help on questions. It's not cheating as if you don't do it on the test, and if you don't do it on every question. And ask it to explain things to you. Because like things like Gemini are really good at like giving you the steps behind what work you need to do. And it can explain any problem you want. This is just a general kind of overview. This is the best I can do right now. So I wish you luck on your test. I have put a lot of time into this, and I hope you enjoy. I have to do my work now. Bye bye now.